How to prove irrationality of numbers? In order to prove the irrationality of numbers, we use a theorem based on fundamental theorem of arithmetic. We call it a theorem px square, which implies px. This is just to remember. So let's say let p be a prime number. If p divides x square, then p divides x, where x is a positive integer. Let the prime factorization of x be as follows. X is equal to p1, p2, p3 till pn, where all p are prime numbers and are not unique preferably, where p1 and p2 till pn are primes not necessarily distinct. So if we do squaring of both sides, we have x square is equal to p1, p2 till pn multiplied by p1, p2, pn again, which is equal to p1 square into p2 square into p3 square till pn square. Given p divides x square and applying fundamental theorem of arithmetic, p is one of the factors of x square. Using the uniqueness part of the fundamental theorem of arithmetic, we see that p1, p2, p3 and so on till pn are the only prime factors of x square. P is one of p1, p2, p3 and so on till pn, which implies that x is equal to p1, p2, p3 till pn and p divides x. So we have proved the theorem that a prime number that divides square of a number also divides that number. This new theorem will be used extensively to prove the irrationality of other numbers. So let's take an example. Prove that root 2 is an irrational number. Applying proof of contradiction, let us assume that root 2 is not an irrational number or it is a rational number. So if it is a rational number, root 2 can be expressed in the form of p by q or a by b, where a and b are co-primes, that is, their HCF is 1. If that is the case and we square both the sides, we see that 2 is equal to a square by b square, which implies that a square is equal to 2b square, which implies that a square is a multiple of 2. Now here if we apply the theorem px square implies px, that means if there is a prime number that is part of the square of a number, then that prime number is also a prime factor of the root of the number. Taking that into consideration, we see that a is a multiple of 2. So let's mark this as equation 1. Now let's assume a is equal to 2c for some integer c. Squaring both the sides, we have a square is equal to 4c square, which in turn implies that 2b square is equal to 4c square. In turn, this is equal to b square is equal to 2c square. Now if that is the case, then b square is a multiple of 2 also. From 1 and 2, a and b have at least 2 as a common factor, but this contradicts the fact that a and b are co-prime. Because remember, co-prime numbers just have two factors, 1 and they themselves. This means that we are contradicting that root 2 is a rational number, which implies that root 2 is an irrational number. It's time that you build your attention by visiting WaHPACT.com. Just go to the various courses and try some challenges. Happy learning!